The Sun is the star at the center of our solar system, a massive ball of hot plasma undergoing nuclear fusion at its core. It radiates energy mainly as visible light and infrared radiation, with a small fraction in ultraviolet wavelengths. This energy is essential for life on Earth, driving processes like photosynthesis and the climate system. Throughout history, many cultures have revered the Sun, and it has been a central subject of astronomical study since ancient times. The Sun orbits the galactic center at a distance of about 24,000 to 28,000 light-years. From Earth, the Sun is one astronomical unit, about 150 million kilometers or 93 million miles, away, with light taking roughly 8 minutes to travel from its surface to Earth. The Sun's diameter is around 1.39 million kilometers, making it 109 times wider than Earth, and its mass is about 330,000 times that of Earth, representing 99.86% of the solar system's total mass. Its composition is primarily hydrogen, 73%, and helium, 25%, with trace amounts of heavier elements like oxygen, carbon, and iron. A G-type main sequence star, G2V, the Sun formed around 4.6 billion years ago from the collapse of a molecular cloud. This collapse led to nuclear fusion in its core, which powers the Sun's radiance. Every second, the Sun fuses approximately 600 billion kilograms of hydrogen into helium. However, as hydrogen in the core depletes, the Sun's core will become denser and hotter, eventually causing the Sun to expand into a red giant in about 5 billion years, making Earth uninhabitable. After shedding its outer layers, the Sun will become a white dwarf and slowly cool over trillions of years. The term Sun comes from Old English sun, with cognates in other Germanic languages. In science, the term solar is used to describe anything related to the Sun. The symbol for the Sun is a circle with a dot in the center, and the term Sol is used in scientific contexts to distinguish our Sun from other stars. The Sun is by far the brightest object in Earth's sky, with an apparent magnitude of 26.74, which is over 13 billion times brighter than Sirius, the next brightest star. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth, and its energy supports life on Earth, influencing weather and climate. The Sun's density decreases as one moves away from its surface, and it has no defined boundary. Its equator rotates faster than its poles, creating differential rotation due to heat transport and the Sun's magnetic field. The Sun's composition is primarily hydrogen and helium, with smaller amounts of heavier elements like oxygen and carbon. These elements were produced in the early universe and by earlier generations of stars. Over time, the proportion of helium in the Sun's core has increased due to fusion processes. In the future, the buildup of helium will eventually lead to the Sun's transformation into a red giant. The chemical composition of the Sun is similar to the primordial solar system, with heavy elements measured through spectroscopy and meteorites. The Sun's core, which accounts for about 25% of its radius, is the only region where significant fusion occurs. In this region, the Sun generates vast amounts of energy by converting hydrogen into helium through the proton-proton chain reaction. This process releases energy in the form of light and heat, which is transferred outward through successive layers of the Sun, eventually reaching the surface. Fusion occurs at an incredible rate, with trillions of protons fusing every second, converting a small fraction of their mass into energy, which sustains the Sun's output for billions of years. The Sun, located at the center of the solar system, is a massive star composed primarily of hot plasma, where nuclear fusion occurs in its core. This fusion process releases energy in the form of visible light, infrared radiation, and a small fraction of ultraviolet radiation. This energy is vital for life on Earth, driving photosynthesis and shaping the planet's climate. The Sun has been a subject of reverence and scientific study throughout human history. Orbiting the galactic center at a distance of 24,000 to 28,000 light-years, The Sun is one astronomical unit, about 150 million kilometers or 93 million miles, from Earth. Its diameter is approximately 1.39 million kilometers, 109 times wider than Earth, and it has a mass that is 330,000 times greater than Earth's, accounting for 99.86% of the Solar System's total mass. The Sun's composition is mostly hydrogen, 73%, and helium, 25%, with trace amounts of heavier elements like oxygen, carbon, and iron. Formed around 4.6 billion years ago from the collapse of a molecular cloud, the Sun is a G-type main sequence star, G2 volts. The collapse led to nuclear fusion in its core, which powers the Sun's energy output. Each second, the Sun fuses approximately 600 billion kilograms of hydrogen into helium. However, as the hydrogen in the core diminishes, the Sun will eventually expand into a red giant, making Earth uninhabitable in about 5 billion years. After shedding its outer layers, the Sun will become a white dwarf and gradually cool over trillions of years. The English word sun comes from the Old English sun, with related terms in other Germanic languages. In scientific contexts, solar refers to anything related to the Sun, and Sol is used to distinguish our Sun from other stars. The Sun's symbol is a circle with a dot in the center, representing its essential role in astronomy and timekeeping. The Sun is the brightest object in Earth's sky, with an apparent magnitude of 26.74, about 13 billion times brighter than the next brightest star, Sirius. It takes roughly 8 minutes and 20 seconds for light from the Sun to reach Earth. Its energy is crucial for supporting life and driving weather patterns. The Sun's density decreases as you move outward from its surface, and it lacks a well-defined boundary. Its equator rotates faster than its poles, creating differential rotation. The Sun's composition is largely hydrogen and helium, with smaller amounts of heavier elements that were produced in earlier generations of stars. Over time, fusion processes have increased the proportion of helium in the Sun's core, a trend that will continue as it ages. Eventually, the Sun will transform into a red giant as its core accumulates helium. Its chemical makeup is similar to that of the early Solar System, with heavy elements measured using both spectroscopy and meteorites. In the Sun's core, nuclear fusion occurs, generating enormous amounts of energy by converting hydrogen into helium. This process releases energy in the form of light and heat, which is transferred outward through various layers of the Sun before reaching the surface. Fusion takes place at an incredible rate, with trillions of protons fusing every second, converting a small fraction of their mass into energy. This process has sustained the Sun's energy output for billions of years and will continue until it exhausts its hydrogen fuel. The first long-term solar observations from space began with NASA's Pioneer satellites, 6-9, launched between 1959 and 1968. These satellites orbited the Sun at a distance similar to Earth's and provided early insights into the solar wind and magnetic fields. Pioneer 9 was particularly successful, transmitting data until 1983. In the 1970s, Helios spacecraft and Skylab's Apollo telescope mount gave scientists more data on solar wind and the Sun's corona, discovering coronal mass ejections and coronal holes linked to the solar wind. In 1980, the Solar Maximum mission was launched to study solar flares in gamma rays, X-rays, and UV radiation during a period of high solar activity. After an electronics failure, the satellite was repaired by astronauts aboard the Space Shuttle Challenger in 1984, allowing it to capture thousands of images of the solar corona until its re-entry in 1989. Japan's Yohkoh satellite, launched in 1991, also studied solar flares in X-rays, revealing the dynamic nature of the solar corona and flares' varied types, before it was destroyed in 2005 after losing its lock on the Sun. The Solar and Heliospheric Observatory, SOHO, launched in 1995 by NASA and the European Space Agency, remains operational. Positioned at the Lagrangian point between Earth and the Sun, SOHO provides continuous solar observations at multiple wavelengths and has discovered numerous sun-grazing comets. In contrast, the Ulysses spacecraft, launched in 1990, studied the Sun's polar regions, revealing surprising findings about the solar wind and magnetic waves at high latitudes, as well as their effects on galactic cosmic rays. While the composition of the Sun's photosphere is well understood, the interior remains less clear. The Genesis mission was launched to study solar material directly by returning solar wind samples to Earth, aiming to enhance our knowledge of the Sun's inner composition. These space missions have been instrumental in advancing solar research and understanding the Sun's behavior. Viewing the Sun with the naked eye can cause temporary blindness and retinal damage due to the intense brightness and UV radiation. Though it is safe to glance at the Sun during sunrise or sunset, prolonged exposure or using improper optics can lead to permanent eye damage. Special filters designed for solar observation are essential for safely observing the Sun through telescopes or binoculars. The Sun has played a significant role in religious and cultural symbolism. Many ancient civilizations worshipped solar deities, such as Ra in Egypt, Surya in Hinduism, and Sol in Roman traditions. The Sun's worship and its representation in various mythologies often symbolize life and vitality. The Sun's role in ancient cultures, including its alignment with seasonal events like solstices, influenced rituals and the construction of monuments, such as Stonehenge. In Christianity, the Sun symbolizes Christ in some interpretations, and the practice of standing in sunlight at dawn was a part of pagan worship, later adopted by Christians.